Greetings and welcome to the problem set, the first problem set for our double angle identities or our double angle formulas. It is page 415, 1 through 14, number 16, 23 through 26. And I'd like you to at some time attempt 16, but I assume we will discuss that as a class. It's a rather lengthy problem, but I would like you to at least attempt it. Now I will do selected problems. The problems I will do is I think 1, 3, then I will do 6, 9, and 26 to give you some help and guide as we work these problems. But remember, you do have the notes that we've given in the previous lesson that should help you on all of these immensely. Now, sine theta for this given is a basic problem from our past, blast from the past. We have a right triangle and I can figure out what sine is. Remember that sine is opposite over hypotenuse, just getting us back into the terminology that we had in right triangle trig. And we see that our opposite of this angle here, theta, will be in fact 1 over radical 17. Now the reminder is we like to rationalize, and rationalizing this will give us radical 17 over 17. Now for problem 3, we're going to work with the same triangle, and in this case we're looking at cosine 2 theta. Now to do this, we would first like to acknowledge what in fact is cosine of theta. And if we look up here, cosine of theta would say we have the adjacent, which is 4, over our radical 17, or simplified in a rationalization way, 4 times radical 17 over 17. And we'll need that. Now if we look at our double angle formulas, we'll see that this 2 cosine theta is actually equal to 2 cosine squared theta minus 1. Now what that gives me is that I have a 2. My cosine theta is the 4 radical 17 all over 17, and that is going to be squared. And then we subtract 1 from it. Now, in squaring this, I will end up with a 16 times a 17 all over 17 times a 17 in my parentheses. Well, we can take out one of the 17 from top and bottom, leaving me with a 2 times a 16 all over 17 minus 1, better written as 32 over 17 minus 17 over 17, which gives me the result of 15 over 17. So that covers our first 2 problems. Now if we look at number 6 here, 2, or secant of 2 theta, I need to be reminded that this could also have been written as 1 over cosine 2 theta. So I could work my problem out like that, or I could simply work the problem for cosine 2 theta and then flip it in the end as a reciprocal. Okay? And this tends to be my favorite way, but let's look at the first way. If we do this, I will have a 1 over a cosine squared theta minus sine squared theta. Now remember, we have a few choices for what we make cosine 2 theta look like, and in this problem I'm choosing to make it look like the square of cosine theta minus sine theta. Now the reason I do that is because I know it's going to work real nice with my fractions that I had above, and I will leave it as a 4 radical 17, which I will square for the cosine, and subtract it, the sine squared theta, which is a 1 over radical 17. Now I chose these fractions from the values I found up here because I know I'm going to square them. And squaring will simply get rid of the radicals in the denominators. So I have 1 over 16 over 17, subtract 1 over 17. Now this will give me 1 over the fraction of 15 over 17, which means as a reciprocal, or I bring this up on top, I will have 17 over 15. And there is my solution. Now had I chose to do the same thing over here and then flip it, I would have cosine squared theta equal cosine 2 theta equals cosine squared theta minus sine squared theta. Now what I have then is my same fractions of 4 over radical 17 squared minus 1 over radical 17 squared, which will give me, as we've seen before, 16 over 17 minus 1 over 17, or 15 over 17. Now I need to remember that I need to do the reciprocal of this. So I flip it, giving me 17 over 15. Advancing to number 9, I have a sine 2x. And so again, I do think it helps us to put in these parentheses. Minus a sine x equals 0. And I'm supposed to solve for this. And as I solve for this one, I just want to make note that I will adjust this by getting rid of the sine 2 theta, the double angle, by replacing it with 2 sine x cosine x minus a sine x, and that is equal to 0. Now what you'll see, or hopefully acknowledge, is that I have a binomial and each contains a sine x. So I will factor out a sine x, leaving me with 2 cosine x minus 1. Setting that equal to 0, I have my two factors. Using the 0 property, I now have sine x equals 0, and, or in this case an or, one has to happen, or the other has to be equal to 0. I have a cosine x equals a 1 divided by 2, so a 1/2. Now remember, that is begotten from the opposite of -1, and then I divide by the 2. Now where do these two things take place? Well, for my 0, it happens at both 0 and pi. Remember, sine x is considered the y value on a circle centered at the origin. If we look at the cosine, we will have the values of pi over 3 and 5 pi over 3. So there are my 4 solutions for this problem. Last but not least, we're going to look at number 26. And this is given the cotangent u equals -4, and we're in this restrictive domain that u falls between 3 pi over 2 and 2 pi. This basically tells me I'm working in the quadrant 4. Now, that being true, I know that tangent is the reciprocal of cotangent, so the reciprocal of this -4 is -1/4. Now, as we had just said, this will happen in quadrant 4. So down here. What will happen? Well, we'll have a distance for my sine, for my x value of a 4 and my y value will be -1. So I will have a right triangle with two legs of 4 and -1. Now what does that give me for a hypotenuse? Well, if I do the quick work, Pythagorean theorem, I get radical 17. So how does that apply to our problem? Well, our problem actually asks us three parts. It says find the sine of 2u. So if I'm going to find the sine of 2u, I'm going to set it to my formula of 2 sine u cosine u. Now I haven't yet determined what those are, so I'm going to go back here and I'm going to look at this saying, well, apparently my sine u will be opposite, -1 over hypotenuse, radical 17, or I could think of it as negative radical 17 over 17. Likewise for cosine u, use my trig. I will do the adjacent, which is 4, over the hypotenuse of 17. And again, I could rationalize that and see it as 4 radical 17 all over 17. Now I'll have my choice of which of these fractions I use or figure out would work best. So in this first process, I'm going to take 2 and I'm going to times it by the -1 over radical 17, and I'm going to times that by the cosine of 4 over radical 17. Now why I didn't choose the rationalized version is because I see I'm going to have a radical 17 times a radical 17, which will give me 17 in the denominator. So hence it takes care of itself. In the numerator, I have a -8, and that is my solution. Now I need to go on to B. Hopefully I'll finish all three of these. Cosine 2u. Again, I'm going to choose the formula of cosine squared u minus sine squared u because I am dealing with radicals in my problem. So it should take care of itself. So what I have then is a 4 radical square root 17 squared minus a 1 that's negative over a radical 17 squared. Now what that gets me for values is 16 over 17. Subtract from it a 1 over 17. So my final result for this problem is 15 over 17. Now, I need to scroll up a little bit and we'll look at our final problem, part C, the tangent to u. Now this one gives us the formula 2 tan u all over 1 minus tan squared u. In my problem then, I have 2 times the fraction, -1/4, all over 1 minus -1/4 squared. When I work this problem a little further, I see that I have a -1/2 in the numerator and a 1 minus a -1 over 16 in the denominator. Further simplification gives me a -1/2 over a 15 over 16 fraction. So I will bring that up, multiply by its reciprocal, and I should see again some reductions with the 2 and the 16 giving me an 8. So I end up with a -8 over 15. And there you have it. I appreciate your time and good luck if you begin this problem set today before class.